Welcome everyone to the next lesson in this series, and in this video we will look at multi-network using Multus and Macvlan CNI. So first of all, let's look at why a pod in a cluster would require multiple network interfaces. Now this is not a very common use case. The bulk or the majority of your workloads will only require a single pod interface. However, in certain specialized use cases such as those in telco environments and now increasingly in AI workloads as well, a pod may require direct access to the underlying network infrastructure. And in those cases, you could use something known as Multus, which can orchestrate multiple CNIs, and you could use specialized CNIs to plumb an additional interface to the pod and provide it direct access to the underlay network. So in this lab, let's look at how you can configure such a setup. Let's get started. All right, so I have already gone ahead and deployed the lab in my environment, and you could do so by following the instructions in the lab video. And if I do a kubectl get nodes, I'm able to see the nodes in my cluster. So my cluster is currently up and running. So let's look at the topology for this lab. This is the one over here. We've used this topology consistently in few of the labs right now. We have VLAN 10 to which the primary interface of the nodes are attached. And there is a pod network, and the pod side is 192.168.0.0/24. Now in this lab, we will be making an adjustment. We will introduce an additional VLAN known as VLAN 20. And if you look at the nodes, they have an additional interface as well, ETH2. And ETH2 is connected to VLAN 20. And we're going to use ETH2 as what is known as the parent interface for the pod's MacVLAN interface. Now, remember, this interface is in addition to the pod network, right? These pods still have an interface in the pod network, but in addition to that, we will be configuring another interface using MacVLAN CNI, and ETH02 is going to be the parent interface for these secondary pod interfaces, and ETH02 is connected to VLAN 20. And this way we can ensure that the pods get an interface in VLAN 20 as well. Now, the main difference between the pod primary interface and this secondary interface is that with a Mac VLAN interface, the pod is a first-class citizen in the underlay network. As in the underlay network in VLAN 20, these pods will be visible. That's not the case with the pod's primary network. The pod network by default is contained within the cluster. Your underlay network or the network outside the cluster does not see the pod primary interface. However, in this case, it's going to be able to see the secondary interface of these pods. Now, in this lab, we're going to start off by configuring what is known as Multus. Multus is what is also called a meta CNI plugin. It's able to coordinate multiple CNI invocations. And in the nodes in this cluster, we will deploy MacVLAN CNI, which is another CNI plugin. And this will be deployed in addition to Calico CNI, which we have installed as part of the cluster setup. Now, Multus, based on something known as a network attachment definition, which we will also configure, will be able to invoke MacVLAN CNI to configure the secondary interface for the pod, and the network attachment definition will have the spec for what that CNI configuration should entail. Now, once configured inside the pod, we will be able to see two different interfaces. The first interface will be the default V8 pair, which is the pod network, the primary interface of the pod. And we're going to be able to see a second interface as well, which is the MacVLAN interface. And in the pod routing table, you're going to have a default route to the primary interface and more specific routes pointing to the secondary interface, and we will explore that in the lab guide as well. All right, so in your lab, once you've confirmed that your nodes are in a ready status, what we can do next is do a Docker exec into the nodes and do an IP link show for the ETH2 interface. Now, the ETH2 interface is the interface that is connected to VLAN 20 in our topology, and the ETH2 interface was provisioned as part of the container lab topology setup. Now, in the lab folder, there's a file called topology.clab.yaml. And if you open that file, you can see how the ETH2 interface is configured. And this ETH2 interface attaches to VLAN 20 ports in the upstream switch. All right. But beyond that, we've not done any configurations for this interface. It doesn't even have an IP address in the node. Okay, so once you've configured the status, or rather confirmed the status of the ETH2 interface, you can next go ahead and install Multus CNI. Now this CNI, we will be installing, or rather it will deploy a daemon set in all the nodes of the cluster. And that provides Multus the ability to coordinate between multiple CNI plugins inside those nodes. So let's wait for those pods to come up. All right, so once the Multus pods are deployed, we can look at the Multus configuration in one of the cluster nodes. So let's look at the Multus setup in the control plane node. The conf file can be found in etc cni net.d folder. And the name of the conf file is 00-multus.conf. And this 00 matters because the sequence of the files in that folder matters. And we will look at that shortly. So copy this config, and that will spit out the contents of the conf file. Let's look at the output here in the left. So this conf file has this delegates section. And in that section, you can see Calico CNI with Calico IPAM. And what this essentially means is that Multus will delegate or invoke Calico as the first CNI for this cluster to configure the pod's primary network interface. Now, if you look at each of the nodes in the cluster, there are a couple of very important directories. The first one is the net.d directory in etc CNI. And this directory holds the configuration files for the CNI and IPAMs for this cluster. And the opt CNI bin folder holds the binaries that basically execute the CNI function. And it's the binary that plumbs the network and configures the routing. Now, if you look at the CNI invocation process, when you create a pod in the cluster, Kubelet scans the net.d folder and it'll pick the first file in alphabetical order. And that's why the 00 prefix in the Multus conf file is important. That ensures that Multus gets picked up as the first configuration file. Kubelet reads the contents of that configuration file and executes the relevant binary. So it reads the contents of the Multus configuration file and executes the Multus binary. Now, Multus next delegates the primary CNI function to Calico as per its conf file, and Calico creates the ETH0 interface. Now, Multus will also check whether the pods have any other annotations for secondary interfaces, and that's what we will configure next. And if the pod has those annotations, Multus will invoke the applicable CNI plugin to create those additional interfaces, right? So this is how the end-to-end process works when interfaces are created in a pod using Multus. Okay, so next let's check the contents of the net.d folder in the control plane node. And if you look at the directory, it has few configuration files, and Multus is the one that is first in the list here with its 00 prefix. So what that means is Kubelet picks this file to plumb the network as part of the pod creation process, right? And what you can also do is you can check the bin folder as well to look at the binaries that are available for this node. And you can see the Multus binary. There are some other binaries as well. And as part of this lab, we'll also configure Macvlan, and you will be able to see Macvlan in the binary list as well. And the binary is what essentially does all the work under the hood to plumb those interfaces, right? So in this case, Kubelet picks the Multus conf file, runs the Multus binary, and the conf file goes as an input to the binary. And in the Multus input, it delegates the creation of the first interface to Calico. And in the Calico conf file, Calico uses Calico IPAM for its IP address management. All right. And that's how the sequence works. Now, next in the lab, we're going to configure something known as whereabouts IPAM. And in this node, although you have Calico IPAM, remember that Calico IPAM is only providing IP addresses for interface created by Calico CNI. Now, in this lab, we're going to be creating a secondary interface as well using Macvlan. And for that, we will use another IPAM plugin known as whereabouts IPAM. And whereabouts IPAM will be able to provide Macvlan IP addresses for those secondary interfaces. So let's go ahead and do that. So start by applying these manifests. And once applied, you can deploy the whereabouts daemon set and we'll wait for that to come up. All right. So once the whereabouts daemon sets are up, you can confirm that the CRDs have been successfully installed. Now, with whereabouts complete, next we will install the Macvlan CNI plugin, right? So copy this commands and install the CNI plugin. This is going to deploy the binaries in all the nodes in the cluster. And once done, if you check the binaries folder, you're going to see Macvlan as a CNI plugin as well. All right, so with that done, let's look at how Multus invokes Macvlan for the secondary interface. Now that is specified using something called a network attachment definition. In your clusters, you can have these network attachment definitions, and these definitions, they specify the CNI. So in this case, the type is Macvlan. We also specify the interface. So the master interface for this Macvlan interface is ETH2. And if you remember in the topology file, ETH2 is the interface that's connected to VLAN 20 in the nodes in this cluster, right? And it also specifies the IPAM. So in this case, where you're going to use whereabouts IPAM, we specified a range of IPs for the IPAM, and whereabouts will provide Macvlan an IP address that it'll then configure in the secondary interface of the pods. And Macvlan will also configure the routes in the pods, a specific route you will see in this case with 10.10.21 as the gateway, and 10.10.21 is the IP address of VLAN 20, the gateway of VLAN 20 configured in the router. So this is our network attachment definition, right? And this is something that we've specified. So next, let's go ahead and apply the network attachment definition so that it's available for pods in the cluster to reference, okay? Now with that network attachment definition applied, let's look at the definition of a pod that we will create in this cluster. This is a regular pod, a very simple netshoot pod. But in this case, we also have an annotation that references the network attachment definition, right? So when the pod is created, Multus will be able to see this annotation and based on the network attachment definition, invoke the necessary CNI to create the secondary interface. So let's go ahead and create that pod and make sure the pod is up and running. So it's still in a creating state. Let's give it a minute. Okay, so once the pod is running, you can do an IP ADDR show for that pod to look at the interfaces inside the pod. Now, in the previous lessons, when we looked at the pod interfaces, we only saw ETH0, which is the pod's primary interface. But in this case, we're also seeing an interface called net1. And this interface has received an IP address of 10.10.20.100, right? And if you remember in the network attachment definition, we had a IP range specified and 100 was the starting IP. So next, let's exec into the top of rack switch, right? The Arista CEOS image. Let's do an enable here. And if I do a show MAC address VLAN 20, what you're going to notice is that the switch has learned a MAC address, and it's this MAC address over here, 6AEC. And if you look at the MAC address of the net1 interface, it is 6AEC as well. So if you look at the full MAC address, it corresponds with the one the switch has learned. All right. And this is what I mean by this interface being a first-class citizen of the network. This interface has direct visibility to the underlay network, which is not the case for your regular pod interfaces. So that interface right now has direct connectivity to VLAN 20 in our network setup over here, right? And what we can also do is, from the switch, we can directly ping the IP of that secondary interface in the netshoot pod and we receive a response. And if you look at the ARP table, if you do a show ARP, you will be able to see an ARP entry for that IP as well. And the ARP entry maps to the MAC address of that interface. Okay, so I can exit from this, and what we can do next is I'm going to deploy a daemon set. It's a very simple daemon set. It's very similar to the pod that we create. It's going to have an annotation for the network attachment definition. And once the daemon sets are up and running, let's go back to the switch and try to ping the IP addresses of those pods. Okay, so the daemon sets are up and running. So if you look at the interface in the kubectl output, it's going to have the primary interface of those pods. But if I go back to my top of rack switch, I'll be able to, I'm just going to ping some random IPs, 10, 10, 20, 100, 101, 102, and 103. And so no response for 104. And that's because this is a 3-node cluster. And as part of that daemon set, we spun up 3 additional pods. And as you can see, those pods received IP addresses 101, 102, and 103, right? If I do a show up now in the switch, we see the 4 pods, right? The first one is the test pod that we created. As you can see, it had received an IP address of 100 from whereabouts IPAM. And these pods are in different nodes. If you look at the switch port here, ETH4 is, if you look at our topology, ETH4, Ethernet interface 4 is connected to the control, 5 to worker 1, and 6 to worker 6. And this you can see in the container labs topology, right? So these are the interfaces in the top of rack switch. So ETH4 goes to control plane ETH2, ETH5 to worker ETH2, and ETH6 to worker 2 ETH2, right? And we deployed a daemon set, right? So each node received a pod, and each pod received an IP address from whereabouts CNI, and those IPs are now directly reachable from the top of rack switch. All right. Now, one more thing to note is if you look at the routing table inside the pod, so in this case, let's look at the table inside the Macvlan test pod. You're going to see the default route, and we've looked at how Calico configures this default route. So essentially, all egress traffic from the pod goes out that primary interface. You're going to see this secondary route as well. And what this basically means is for any traffic destined to any other IP in the 10.10.20 range, this is going to be the source IP address. And this is in the same subnet, right? So the switch would, or the pod in this case, would do an ARP and reach that destination IP. In this lab, we've not configured any other additional routes. But if you want to steer traffic to different networks, let's say you have these secondary interfaces and you want to steer traffic to certain destinations out those secondary interfaces, you could do so by injecting routes using the network attachment definition as well. And we will maybe check that in one of the subsequent lessons. Okay, but just bear that in mind. All right, so there's some more content in the lab guide as well, but that's pretty much it for Multus with Macvlan CNI. You looked at how our pods now have direct connectivity to the underlay network. We configured Multus for this, Macvlan for this. We configured a network attachment definition, and we plumbed those interfaces to the pod. I hope you found this informative. That's it for this lesson. I will see you in the next one. Thanks for watching, and bye for now.